So I'm going to jump to my to my PowerPoint. Okay, so based on that video we saw, right, the timing and spacing is important and in to achieve realism or to achieve some kind of a rhythm, right? So the example, the bouncing ball. Okay, if the spacing between balls begin to cluster highest constant speed. So now this the next drawing over here, okay, the ball is actually dropping. Okay, so the ball when it drops from a top space, maybe you throw a ball down. So force being down, right? Okay, the initial frame is drawn very close. The spacing is closer lah. Pull down, it becomes more, it decrease the speed. Okay, so become more slower. Means that the keyframe or the spacing between the frame is bigger lah. Okay, so do you imagine that the curve, okay, it's really not linear now. Okay, so maybe there's a maybe ease out. Okay, so ease out, maybe this part is faster or smoother. Okay, and then it no, ease out. I think this is very steep. Okay, because the keyframe, okay, is drawn closer, means that it's move very slow. Okay, and then ease out, so this move very slow, and then after that this below here, right, this part when it's falling, it's become faster lah. Okay. In terms of bouncing ball, right? Okay, bouncing ball. Okay, so the ball when it bounces, it will bounce in. Okay, we call this parabola, up of a parabola. Okay, so normally object, if you look, okay, look at the especially in animation. Okay, an object when it falls, right? Okay, you will create like this parabola. Okay, this parabola means that it's like a semicircle. Okay, it's an arc. Then the movement, right? Okay, the movement when we are talking about the bouncing ball. Okay, if you apply this, okay, this bouncing ball, right, to this out, right? Okay, okay, let's say when you drop, when it start to bounce back, right? So when it bounce up, right, it will be very fast, and when it reach the top here, right, it's going to, the momentum is going to be slower, okay. So this slow means that this keyframe is drawn closer, all right. So while the while the path of the arc remains constant, parabola, okay, the parabola here remains constant, right? The spacing of the ball throughout the arc varies as the dynamic varies. Okay, this spacing, right, it's actually being affected by the gravity lah, right? The gravity. Okay. So also consider the amount of force. Okay, amount of force being used to throw at this ball lah. Okay. So the more force, the faster the parabola is. Okay? The lesser force maybe not so, the arc of the parabola maybe not so big lah. Alright. Okay. You notice that the top part here. Okay, the top part here, the ball. Okay, it's drawn closer lah. Okay, ball here is drawn closer. And yeah, below here are much, so this closer means that it's very slow. I mean, not very slow, I mean it's slow. Okay, as it goes down, right, it becomes more faster. Okay, so okay, just to take note, in terms of animation, so we need to understand a bit of this, the arcing, okay, and the parabola, okay, the parabola which is this arc, okay, and also this, okay, this thing here, right, on top here, right, they refer in animation, right, they refer it to as a apex, APEX, okay, apex. So the apex is the highest, okay, the height of the object that is being thrown to. Okay, so for example, this ball, right, okay, the highest distance, okay, that's where the apex is. Okay, the apex of the arc, right? Next is okay. So okay, we really need to understand how this moves before we can apply this to a bouncing ball. Okay, so timing throughout a bounce. Okay, so now if you look at this diagram or this drawing, right? Okay, this is the arcing, okay, the parabola of the bouncing ball. Okay, so and also these are some of the in betweens and the key framing being shown here. Okay, so the key frame, the key post is from 1. Okay, the ball start from frame 1. Okay, this is the height, and then being dropped. Okay, when the ball drop, okay, it move to frame 6. Okay, so from frame 6, it jump back to frame 11. Okay, so the apex is at frame 11. Okay, this is the highest point, and then it move down back to frame 16. Alright, and then jump back up 20 and so on. Alright, so the closer, okay, the drawing are close together at the top of the up, then they are at the ground level, the same thing. Okay, so if you refer back here, on the top here, the drawing are closer. So this top here, the apex here is where the ball is, the least speed, the slower it move. Okay, so the drop here is very sharp, okay, very sharp and very fast. So doop, and then go back upward. Okay. Now, if you understand this, right? So when we use, especially to create a bouncing ball, right? We can use the F curve, okay, to fine tune our curve according to this arc of parabola, lah. Okay. Now, when on top of creating the spacing, okay, we to create a convincing bouncing ball, right? We also need to use the squash and stretch. Okay. So the ball squashes on impact with the ground. When the ball hits the ground, okay, it start to squash lah. Okay, the ball when it goes back on the air, okay, the ball regains its shape. Okay, the top of the parabola, which is the apex. Okay, so when it reaches the apex, it regain its original shape. Okay, the ball stretches as it falls to the ground. When it drop to the ground, okay, before it hit the ground, right, it's dropping, the ball is being stretched. Okay, stretch a bit. Okay, so and so on. Alright, so the when the original shape is from the dropping point. Okay, when it drop, okay, that's when you can apply the stretch. Okay, when it hit the ground, okay, the ball squash lah. Okay, the ball shape is being squashed, and then when it move upward again, stretch a little bit, and then again its shape, and so on. Okay, so I think you can use this as reference, right, to animate the bouncing ball lah. Okay, to animate the bouncing ball. Okay, so very important that we need to understand the spacing lah. Okay, the spacing, the this spacing, right, from which frame to which frame it start to bounce or we start to go back upwards. Okay, so another thing to consider when we are creating the bouncing ball, okay, is the rotation. Okay, all object moving in free flight under gravity move in parabola. Okay, so not any, just all object, okay, when it's fall, okay, and it will move according to its own parabola. Okay, a thrown hammer spinning through the air rotates around its center of gravity, but center of gravity itself travels on the parabola. Okay, so when imagine this hammer is being thrown upward, okay, it's not just thrown. I mean, the hammer, okay, it will somehow rotate, okay, based on its center of gravity lah. Okay, center of gravity. So it will rotate, and then when it drops, so it will continue to rotate. Okay, so the same thing with this the bouncing ball. Okay, this bouncing ball, it will rotate slightly, okay, according to the parabola. Okay, very important, when the bouncing ball rotate, right, it must direction according to its own. Okay, if you rotate a different angle, right, it look awkward and it's not realistic, basically. Okay. Any question regarding this? Hello?
Nope.
Right. So this PDF file, right, I've uploaded inside the MS Team. Okay, and okay, I will upload in my collection also lah, but it's inside the MS Team, the 3D motion graphics file. You can retrieve it from there lah. Okay. No question regarding this? Yes.
No.
Okay. So no question, then we jump to the demo, which is okay. So this is the example which I did, the bouncing ball lah. Okay, so we understand that the ball bounce according to its this curve, right? Is it's the parabola. Okay, and then I also apply the squash and stretch. All right. Okay, so next is I'll show you in how to create the bouncing ball in Cinema 4D now. Can I just ask, right? The video which I uploaded, right? I don't know, I can't see it, but you guys managed to download the video? Yeah, this video tutorial. Is it inside the MS Team? Hello. The video tutorial, do you find it inside the MS Team?
No.
The tutorial inside MS Team, it's not there.
No.
Sorry, am I lagging? No.
Yes, you're lagging a little bit, but cannot find the file.
Okay, next is I'll show you the bouncing ball. Okay, so first create the bouncing ball, we create a spear, right? Then apply the squash and stretch deformer to the bouncing ball, right? Before we start to animate, so right, make sure the settings is set accordingly. Then for the squash and stretch, we bring down the squash and stretch to -100, okay, and then increase the top, and the bottom we set it to 0. Okay, why we do it? Because we want our center factor, right? Okay, to affect the whole object, not from the center, but from the bottom. Okay, so that's why we change all these settings. Alright, so
Yari.
okay. What is that? Okay, so now once we have set all the settings properly, we can set a keyframe to the Y axis, okay, which is the
What? Oh.
Yes, that create a spear. So I'm going to show you again. Create apply the squash and stretch to the spear. Move the spear to -100 degree downwards. Okay, change the top under the object. Change the top to 200 cm. Change the bottom to 0. So when we move, okay, it will affect the entire ball. Okay, so before we start to animate, right, make sure that we go to project. Okay, your project setting, right? Make sure the frame per second change this to 24 frames per second. Okay, 72. Okay, it's fine. Then you can start to animate the ball. So you under the from the y-axis, maybe you add in a different value. Okay, so 600 from the top, you're going to fall from this height. So click on record keyframe, right? And then now I'm going to animate this using the timeline track. Okay, the track globe sheet. Okay, so and I'm going to only animate the y-axis. Okay, I'm going to only animate the y-axis first. So from the y-axis, go to animation and show track. Then y-axis, animation, show track. Okay, so frame 1. Okay, or frame 0. Okay, this is the ball position. Okay, which is at 600 cm height. Okay, then okay, so I refer to this example or these drawings to animate the ball. Okay, so from frame 1, next is frame 6. Okay, so go to frame 6, 5, 6, and then add in a keyframe. So you can click here, record current state, or press Q, will add in a keyframe. So this keyframe should be 0. Okay, so now it move from top, bottom. Okay, next is frame 11. So it move upwards again. So first one is 600, now it drops to 500. Then frame 11, frame 16, 0. So I check. Drop, go up back, drop. Next is frame 20, goes upward again. Frame so 500, now is 400. Next frame 24, it drops down to 0. Okay, so I'm going to continue for every 4 frame. Okay, I'm going to add a keyframe. So 24, go to 28, adding keyframe. So this go down and then go up. 400, maybe this one put 250, 250. And then this one put to 0. Move this to 150. This one put to 0. Okay, so basically I'm getting the ball as it move down the timeline, right? Okay, the bounce become the bounce becomes smaller lah. 100 0 0. Okay, so now when I play, okay, so I've added all the keyframe, right? Based from this dispose lah. Okay, 1, 6, 11, 16, 20, 24, and then for every 4 frame I add in the subsequent keyframe. Alright. Okay, next, you notice that this ball, right, when it's bounce, it looks very rigid lah. Right, very mechanical. So we can use the F curve, okay, to fine tune how this ball move lah. Okay, so frame. Okay, so you see that the ball, right, okay, it's actually, the curve is actually quite smooth lah. Okay, throughout it's quite smooth. Okay, it's not neat. I wouldn't say it's linear. Okay, because it's going down very. I mean, there's a curve lah. You know, there's a curve, then its motion is quite smooth. So I don't want this. Okay, I want it to have a very sharp bounce this way lah. Okay, so what I'll do is I'm going to adjust the bottom keyframe here. Okay, which is the when it hits the ground. Okay, this below here should be sharper a bit. Okay. So when I select this point here, when I start to adjust, okay, when I adjust the handle here, it will affect both the left and right handle lah. Okay, which I don't want it to affect. Okay, I only want to affect one side. So what I'll do is I'll select all the point which I want to adjust, and then I'll choose this brake tangent. Okay, click on the brake tangent. So now when you move, okay, only affect on one side. Okay, so now the ball when it's drop, okay, it will drop in a yeah, you can see how the keyframe appears. The ball when it start to drop, right, the top keyframe is the spacing. Okay, you see the spacing is more. Okay, when it start to hit the ground, the spacing become more closer lah. Okay, let's adjust everything first and see how it looks. Okay, so once I adjust the point, okay, then let's see. Now it looks more believable lah. Okay, how the ball is bouncing. All right. So, okay, still on the same curve. Okay, so this time I'm going to adjust the top. Okay, the top curve. Okay, so adjust it to make it a bit wider now. When I just make it a bit wider, that means that the ball is going to stay slightly a bit longer on the air lah. Okay, before it drop very sharp to the ground. Okay, then all right, so that's the bouncing ball, but this ball is bouncing on at one spot. Okay, only at its same spot. So I want it to bounce in, let's say, it's moving forward. Okay, so maybe it's bouncing and it's moving forward lah. Then what I'll do is I'll just add in a keyframe for this is x-axis. Okay, so under the x-axis, right? Okay, frame 0. Okay, I add in record keyframe here on the x-axis. Go to the the last keyframe, which is 52. Okay, then I'll just extend this maybe to 1200. All right, so now when I play, you see that, guys?
Yes.
Okay, so now the ball is dropping lah. Okay, but this drop is without the squash and stretch yet. Okay, I haven't applied the squash and stretch yet. Okay, so now we take a look at how to apply this squash and stretch. So, okay, the same thing, we're going to add in the keyframe for each factor. Okay, for the squash and stretch. All right, on the factor attribute, right, I'm going to add in a keyframe. Okay, and I'm going to keep on adding or animate this using the same method, which is using the dope sheet on the track. Okay, so right now I'm only looking at the squash and stretch keyframe. So I can drag in the sphere keyframe, the sphere object into the dope sheet. Okay, the sphere object, drag it inside the dope sheet. Okay, so I can compare the entire keyframe. Okay, so I want so I know exactly where is the ball is going to hit the ground. So, right, this is going to hit the ground here. From the drop, initial shape is its original shape, and then when it hits the ground, it's going to squash. So maybe the squash is 70%. All right, squash, go up back. And it's 100. Okay, squash, stretch, squash, original, squash, original, squash, original shape, squash, original shape, original shape. Okay, so I end a keyframe on an alternate. So basically, I add in the keyframe for its original shape first. So I don't have to every time add in the change the value for the original shape. Okay, now I am going to add in the keyframe for the squash. Okay, so for the squash, at frame 16, when the ball hits the ground, add in the keyframe, change this to 70. Okay, go down, add keyframe, change this to 70. Go up, go down, change this to 70. Go up, go down, change this to 70. Go up and go down, change this to maybe less. Oh, too much. 90. Up, down. 90, 100. 82, 80. Okay, so I add in the squash to the bouncing ball first. Okay. So next is the stretch. So for the stretch, right, in between when it's moving downwards, okay, so before it hits the ground, okay, somewhere in between, it will stretch a bit. Okay, so maybe frame 6, frame 3, I add a keyframe here. On frame 3, then change this to 130, stretch, and then squash. Okay, so when the ball is moving, it's dropping in the middle, right? Okay, then you can add in the keyframe. Well, so go down, maybe it's 1 to 0. So the value, okay, the value is decreasing also. Okay, when the ball move, okay, when the ball is decelerating, right? Okay, its stress value will be lesser lah. Okay, so you notice that my keyframe, okay, for the stretch, okay, I did not apply the keyframe for the stretch all throughout the end, okay, because for the towards the end, right, okay, the shape it it, it, it will retain its original, most of its original form, okay, as it decreases. So now when I play the animation, okay, it's bouncing with the squash and stretch. All right. Any question up to this point? Any question, guys?
No.
Nope.
Okay.
Nope.
Okay.
Nope.
The video I will upload, I think I will pass you through Dropbox. Dropbox, this video is quite big, so it's about 1 gig. So yeah, I think I won't send to MS, otherwise it's going to take a lot of space. Okay, so for this animation, right, you see that we applied the keyframe. Okay, we applied the squash and stretch. Okay, the only thing that we need to apply next is the rotation. Okay, so the rotation, if we okay, so the rotation based on these notes, right? Okay, so the object that is moving or falling, okay, it will rotate according to its own parabola, okay, the own arc. So now we apply the rotation, which is, if I'm not wrong, it's under z-axis. Yes. Okay, so under the bank, okay, or z-axis, so z, we're going to animate this z rotation, okay. So for frame 1, you're going to look at the side view to rotate. Okay, so from frame 1, add in a keyframe, record keyframe for the Z rotation. Then when it start to move downwards, okay, so I'm going to change this to slightly, say minus 15, too much. Okay, wait. -4, okay, -4 degrees. Go down, move up backwards. So when it move upwards, I'm going to rotate it according to the same arc, okay, which is this, the arc, -17. Go down, so this one, rotate it this way, -14. So okay, for this rotation, there's no sweet value or sweet number. You need to observe how the ball is moving based on the arc now, the parabola. Okay, so you want it to move the direction based on the same parabola curve. Okay, wait. Here. Okay, keyframe. And keyframe. Okay, so I'm gonna play. Okay, so the rotation is done. Then if you look at the rotation now, it's rotate to the angle according to its one parabola. All right, that's it. Once done with this, you can once I'm done with this, you can go to animate, make preview. Then you will preview inside the picture viewer. Okay, so you can save this out. Okay, and then you can upload this into the same Padlet.